and then we'll jump over to the other worksheet and do a couple. And then we're going to learn some new stuff. So what's the first thing we notice? Okay, we should always look to see what our actual domain is. So we're looking at theta values between 0 and 360. And again, it doesn't matter whether we're calling it theta or x, right? Also notice that even though 0 and 360 degrees are at the same terminal position, both of those numbers are included because we've got a less than or equal to sign, okay? So that's important also. All right, so in order to solve this, I need to isolate the theta. So we're going to do 6 sine theta. We're going to add 3 to both sides, and then we'll divide by 6. So we get 1/2. So that means theta equals the inverse sine of 1/2. And somebody from the other class was asking, do you have to write that? Yes, you do. Although we do typically, this is kind of where our brain goes. This is what we're sort of thinking when we're actually solving it. Because when we're solving it, we're saying, okay, let's think about the unit circle. Where is the sine of theta equal to 1/2? That's what's going through our mind. This is not how our brain is working. However, we are solving for theta. So we do have to write that last thing there, even though our brain is kind of stuck here. Okay, we do have to write that. Without that, we're not actually solving for theta, we're solving for sine theta, right? Okay, so sine theta equals 1/2. So in other words, when we say theta equals inverse sine of 1/2, we're asking ourselves, what angle gives us a sine value of 1/2? So thinking about our unit circle, we're looking at this 30-degree angle. That's our reference angle. So we're going to look at all of those 30-degree reference angles. Okay, so at 30 degrees, the sine is 1/2, so that's good. How about at 150? Is the sine 1/2? No? Oh, yes, it is. I'm sorry. It's positive there, 150. How about at 210? No, because it's negative, right? So yes, yes, no. How about at 330? No, because it's negative. So there's my answer. Okay. Okay, let's look at number 2. We're going to subtract 5, so we get -1 equals cosine theta. So theta equals the inverse cosine of -1. So once again, see how important that unit circle is, right? We need to know our unit circle. Okay, inverse cosine. Okay, so where is the cosine? Cosine is the x value. Where is a cosine equal to -1? Well, let's see. This is 1, 0. Here we have 0, 1, -1, 0, 0, -1. So where's the cosine equal to -1? 180 degrees. Good. Okay. Okay. All right, we're getting harder. So looking at number 3, let's divide by -2. So tangent theta equals 2√3 over -2, which is -√3. So theta equals inverse tangent of -√3. So tangents are hard because it's y over x, so I kind of have to do the math. So I'm going to see if I can get my calculator to help me a little bit. So let me just go we're going to do inverse. Let me make sure I'm in degree mode, and I am. I'm going to do inverse tangent of negative radical 3. And let's see if that gives me anything I can use. Okay, it gives me negative 60. So this is where, it's interesting because so many times I have students say, well, why can't we just use our calculators? We need to understand what we're doing in order to understand the result that we get on our calculator. Okay, so it gave us negative 60 degrees. That means I'm looking at going this direction 60 degrees. Okay, so there's my negative 60 degrees, which is actually 300 degrees, right? Well, what's the coordinate there? Bless you. We're looking at 1/2 negative root 3 over 2. That's the coordinate there. So when the calculator gives me negative 60 degrees, basically what that's telling me is that 60 degrees is my reference angle. So your answer, we can't use negative 60 in our answer. Because look at our domain. It says between 180 and 360. Well, negative 60 is not between 180 and 360. But I can use 300 in my answer. Okay. Where else is a reference angle of 60 degrees? Right, up here at 60 degrees. Can I use that? No, because it's not in the correct domain. Right. So another one with 60 degrees would be right up here. 60 degree reference angle. So that's 120 degrees, and that's not going to work. And then we've got one down here. We're looking at those 60 degree reference angles. So down here, we're at 240 degrees. Can I use that? Yeah. So there's my answer. And I used my calculator to help me get that reference angle. Okay. I will allow you to use your calculator on your quiz. If not, we literally have to go around and we have to figure out which y over x gives me root 3. Okay. So y over x, right? So remember your options when you're talking about those angles. We either have 0, 1, 1/2, radical 2 over 2, or radical 3 over 2. Those are the options for points that I have, right? Coordinates that I have. So I'm not going to be using the 0, the 1, or the radical 2 over 2. So it's got to either be root 3 over 2 over 1/2 or 1/2 over root 3 over 2. It's got to be one of those. Yes.
But if they're both negative in the third quadrant, then why would that work?
Oh, good observation. Yes, very good. Okay, hang on to that. I'm going to show you something else that we're going to do. Thank you. Okay, so without our calculator, we would have to test to see which one of these works. Turns out it would be this one, because that equals root 3. And then we'd have to figure out which angle has that y and that x, okay? Okay, so very good observation. 240 degrees does not work. So let me just take a moment to show you on your calculator when we graph it how we can verify that, okay? So I am going to graph this on my calculator, okay? -2 tangent theta. Okay, learning how to look at things on our calculator and look at the table of values, also very important. And we should use all of that when we're solving these. Okay, -2 tangent theta, and then 2 root 3. So what I'm going to do is look to see where these lines intersect, okay? I'm going to set my window. It said that my x value has to be between 180 and 360 degrees. So I'm going to set it like that. 180 is the minimum. 360 is the maximum. And for a scalar, let's do 30 degrees for a scalar. And I think I can leave my y alone for now. Okay, now when we look at the graph, what are we going to be looking for? Intersection, right. I'm looking to see where they intersect. So we graph it. Okay. Right away, I can see I have a mistake because I had two answers. This only intersected in one spot. Okay. Now we can do a calculate intersect. That's fine. But if I'm just using my graph to double check my work, right? Each one of these marks represents 30 degrees. So we're looking at least I think I did it that way. Yeah. This starts at 180, 30 degrees, 210, 240, 270, 300. Sure enough, they're intersecting at 300 degrees, okay? Or I could do calculate intersection, first curve, second curve. Oops. Okay, it's not letting me pass the first curve. And notice down here where it has y equals, that's because I was in a section of the curve that wasn't on the graph. First curve, second curve, and then my guess, and that gives me 300 degrees, okay? So, right, I almost made a mistake there, right? Looking at the graph should remind us there was only one solution. Yes, Gavin? Okay. Okay. Very good.
So you could do that, like, could you do that for all of them? Like, if you got theta equal inverse tangent?
Sure. Yeah, so if we look at this one, 6 sine theta minus 3 equals 0. So this one, come on. Okay. 6 sine theta minus 3, was it? Okay, so what am I looking for when I graph this one? I'm looking for either the x-intercept, because I'm looking to see where it equals 0, or I could graph it like this. 6 sine theta equals 3. Either way, I'm going to get the same thing. It's just a matter of what you're comfortable with. Okay, 6 sine theta equals 3. So we're going to set our window. This one was going from 0 to 360. Okay, and yep, we said that the solution was at 30 and 150. So graphing it, sure enough, 30 degrees, 60, 90, 120, 150. So we can see that the intersection is correct. Okay, so I like to make the marks so that I can easily count. Okay. And of course, it's going to intersect again, but that's beyond 360 degrees. It's going to intersect at 390 degrees. Okay. So yeah, you can use the graph to help you anytime. Okay. Okay. Yes.
What do the directions mean when they say watch out for extreme solutions?
Okay. So in other words, if you get a solution that looks like a solution but is not, that's not going to happen on numbers 1 through 6. Yeah, but it could possibly happen in the second section, which we have not done yet. Okay. Let's jump down to number 6, because this one has a weird domain and it's in radians. Okay. Okay, so what should we do here to solve? Okay, we're going to get the tangents on one side, so we're going to subtract tangent theta. So we have 2 tangent theta equals 2. And then we'll divide by 2. I love having students like you because in some of my classes, Caleb dropping his book would have been a huge disruption because people would have laughed and pointed fingers. Rah! I just love having mature students. I really love you guys. It's such a joy teaching you. Thank you. Because Jessie is going, Wah! No, I can. Okay. So we have theta equals inverse tangent of 1. Okay. So this means where is the y over x? Where is that equal to 1? So where is tangent equal to 1? Y over x, the y and the x have to be the same. So that's going to be here at these 45-degree angles, okay, which is pi over 4. So looking at this is saying to look specifically from pi over 2 to 3 pi over 2. So I'm looking just in that area there. So if it is a positive 1, that means the y and the x have to be the same sign. So I'm looking just right here. So we've got theta equals 5 pi over 4. And we need to give that in radians. Okay. Now, if I graph this, okay, we're doing tangent theta, and that's going to equal 1. So this time I need to adjust my window. I'm going from pi over 2, that's my x min. When I press enter, it'll change it to decimal. And then I'm going to 3 pi over 2. Okay, now when I solved it, I found my answer to be 5 pi over 4. So my scalars, I'm going to make my scalar go pi over 4. Okay, and let's graph it. Oops, what'd I do? Because that's not a tangent function that I'm looking at, is it? So what's the problem? I'm in degree mode. Again, we have to understand our graph enough to understand the calculator output. Okay, that's why teachers like me that let you use your calculator, we make you learn it without the calculator first. Then you can use your calculator. Yes. That's just talking about the decimal point. So the decimal point is going to float to wherever it's needed. So if I had it on 2, then all of my answers would be rounded to 2 decimal places. Okay. Okay, so there's my graph. All right, we started at pi over 2. And we went by increments of pi over 4. So this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Now, if I do a calculate intersect here, it gives me the intersection in decimal form. That can be confusing. That's why it's important to understand what each mark represents and to set those marks to something that makes sense to me. So I solved it by hand. I came up with an answer of 5 pi over 4, right? So in order to see that when I'm graphing it, I set my scalar to pi over 4. That way I could count my marks to see if it was working. But be very careful. Remember, we started at pi over 2. Pi over 2 is 2 pi over 4. And then we have 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay? So make sure you understand what you're graphing. Okay, questions on that? Okay, let's take a moment to look at the other worksheet. Okay. So let's see here. We're looking at 0 to 360. Once again, pay attention to your domain. In this case, we are not including the 360 degrees. Okay. All right. So I'm not going to do all of them, but let's look at number 2, because that one's kind of weird. So let's see. Yeah, it's kind of a weird one. All right. So my first thought, to be totally honest with you, my first thought was, oh, I'll multiply by 2 on both sides. But that's not helping me any. Right, if I multiply by 2, this becomes, right, that's gone. This becomes a negative 2 plus 2 sine theta, right? So let's see, I've got negative 2 plus the square root of 3. Maybe it will help. Let's see what happens. So if I add 2 to both sides, oh, it does help. Okay, I was going to do it differently. And then divide by 2. So there we are. That's going to help me just fine. Okay. Notice if you, instead of dividing by 2, or multiplying by 2, if you added 1 to both sides, what would happen? So this would be negative 2 plus root 3 over 2 plus 2 over 2, which would be negative 2 plus root 3 plus 2 over 2, which would give us the same thing. Okay, so either way, we're going to get to the same thing. All right, so we have theta equals inverse sine of root 3 over 2. So again, looking at our unit circle, right? Our brain is saying, where is the sine value? Where is y equal to root 3 over 2? And that's going to be right here at that 60-degree reference angle. So we're looking at theta equals 60. Okay, where else is it going to be like that? It's right here at 120. How about 240 and 300? 240 and 300, will they work? No, because sine is negative there. Okay, so it won't work. So there's our answer. Okay. Looking for other weird ones here. Okay, let's do the cotangent. Oh, actually, that one's easy because that's the cotangent theta equals 1, right? Okay, which ones would you like me to do? Did you have any trouble with number 7? Yeah, number 7's a weird one. Tangents tend to be hard because they're y over x. So let's divide by negative 9. And we get negative 3 root 3 over negative 9. So tangent theta equals root 3 over 3. So we're looking at theta equals inverse tangent of root 3 over 3. So again, I have to figure out which y over x I'm using. So I'm looking at root 3 over 2 and then 1/2, okay? I'm pretty sure I'm not going to be using the root 2 over 2. All right, so if I do root 3 over 2 over 1/2, so this would be my y, this would be my x, this is going to equal root 3 over 2 times 2 over 1, which is root 3. So that doesn't work. So it's going to have to be the other one, 1/2 over root 3 over 2. So here's my y, here's my x, which equals 1/2 times 2 over radical 3. 2's cancel, so I have a 1 over root 3, which is root 3 over 3. Okay, so we're looking at where the y is 1/2 and the x is root 3 over 2. So that's right here at the 30-degree angles. So we're looking at theta equals 30 degrees. It has to be positive, so that means this will not work. This will work because they're both negative here. So that's going to work. So that is 210 degrees. This will not work because one's positive and one's negative. Okay, so there's my answer. Right? Questions? Okay. I'm going to give you a brain break. You can wander around, whatever you need to do, and then we will jump in on solving quadratic equations. Okay? All right, so what we're going to look at now is solving equations that are quadratic in form. Okay? So what we have to do, if we look at this equation, this worksheet is actually in your Google Classroom. If you want to pull it up, you can. I don't have a physical copy. I'm sorry. Okay, so let's just look at this. Let's pretend that we're not looking at, let me go one that's a little easier. Is it really warm in here? All right, let's look at number 4 here, okay? So let's pretend, yeah? Oh. Did I put it in the other classroom and not yours? Okay, let me check here. Okay, so I'm looking at number 4. So I'm going to start by adding 5 to both sides. So I've got 0 equals tangent squared theta plus 2 tangent theta minus 3. Okay, everybody understand that? No, it's not minus 3. Wow, I am having some issues. Negative 4 plus 5 is equal to 1. Is that right? Yes. Okay. Okay, so what we're going to do is we're going to pretend that those are not tangents. We're going to just pretend that they are x's. X squared plus 2x plus 1. How would we solve that equation? Factor it. And how is that going to factor? X plus 1, x plus 1. So then x plus 1 equals 0, which means x equals negative 1. We're going to do the exact same thing, but it's tangent instead of x. So we're going to factor this as tangent theta plus 1 times tangent theta plus 1. Okay, so we're factoring it's quadratic in form, and we're going to factor it the same way we would if it was just a regular quadratic equation. So this means I have tangent theta plus 1 equals 0. So tangent theta equals negative 1, which means theta equals inverse tangent of negative 1. Okay, checking our unit circle. If tangent is negative 1, that's going to be here and here. So let's see, that's going to be 135 degrees or 315 degrees. Just double check my domain that I'm working with. Yeah, 0 to 360. Okay. So from this point, everything is the same as what we've been doing, but we had to factor it first. Okay. Questions on that one? Okay. I started with this problem because I was only dealing with tangent. I didn't have different trig identities or trig identities. If you look at number 1, bless you, this presents an additional problem because I have both cosine and sine in the equation. Okay. Now, before I do that, let me just go back to this worksheet. Okay. Try and get one. Okay, let me look at number. So I just said that right? This presents a problem because I have both cosine and sine in the equation. Yet, if I look at this one, I have a cosine and a tangent in the equation. This is not the same issue because if you look at this problem, right, I can factor a cosine theta out of this, and that would leave me with a tangent theta plus 1 equals 0. This is no problem because I can set each one of these out using the zero product rule. Cosine theta equals 0. Tangent theta plus 1 equals 0. I can easily solve each of those equations because now I just have cosine and then I have tangent. In this one, I can't do that. First off, it doesn't equal 0, and when it does equal 0, I'm not going to be able to separate it like that. So let's see what we can do. So I'm going to start by subtracting sine squared. Like that. Let's get it equal to 0 because it is what we call quadratic in form. So let's get it equal to 0. This would be no problem if everything was a cosine. How can I deal with that sine squared? What do we know about sine squared? Yeah.
Sine squared plus cosine squared equals 1.
Excellent. We know, I'm just going to work over here to the side, that sine squared plus cosine squared equals 1. That's our Pythagorean identity. So that means that sine squared is equal to 1 minus cosine squared. So let's substitute that in right here. I'm choosing to substitute the sine squared instead of the cosine squared because I have a plain old cosine in there also. So I want everything to be cosines. Okay. Okay, so that's going to give me 2 plus cosine squared theta minus, I'm going to use parentheses because sine squared is 1 minus cosine squared. So I'm subtracting that. So it's minus 1 minus cosine squared plus 3 cosine theta. Okay. So let's see what we have. 2 plus cosine squared theta minus 1 plus cosine squared theta plus 3 cosine theta. All right. So we're going to combine our like terms. Okay, let me just make some space here. Let's combine our like terms and see if we can figure out how to factor it. Okay, so we have 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. All right. We need to factor that. So I'm going to act like it's 2x squared plus 3x plus 1. That's how I'm going to treat it when I'm factoring it. Okay. Let's say this will factor, let's say 2, 1, 1, 1. Right, that gives me 2 plus 1. So this is going to factor as 2x plus 1, x plus 1. Okay, so we have to know how to factor. So that means this is going to factor 2 cosine theta plus 1, and then cosine theta plus 1 equals 0. Okay, I'm not going to take the time to solve the rest of it. You know how to go from there, right? We set up our 2 equations. And then you can solve that, okay? Anybody have a question so far? Okay. Let's look at number 2. Okay, what should we do? I'll tell you what. Let me let you partner up and do number 2 with a partner. Okay, and then we'll finish it together. I loved some of the conversation I was hearing. You guys are doing a great job. That's Bill.
Yeah.
Why don't you bring the trash can over there? That way you can put the ice and stuff in there. Okay. Okay, we're going to keep going while she cleans it up.
That's so funny.
Okay, so what was our first step here? Bring the 2 over, yes. Good, let's bring the 2 over. So we have sine squared plus 3 cosine minus cosine squared minus 2. Let me just tell you, if you take math in college and you're doing trig, some professors are very, very uptight about, okay, let me just rephrase that. I will just say things like sine squared plus cosine squared. Well, the fact that I'm not including the x or the theta is wrong. But it's such a pain in the neck. Sine squared theta plus cosine squared theta. You know, we're saying it fast, but let me just tell you, most math teachers, especially college math teachers, will really be fussy about that. If you just say sine theta or sine squared plus cosine squared, they're going to be like, nope. Got to be sine squared theta, sine squared x plus cosine squared x, okay? Okay, I just want you to know that what I'm doing is not correct. I know you love that. What's next? Morgan, what did you do next?
You changed the sine squared theta to 1 minus cosine.
Excellent, yes. So, Annalie, why did we choose to change the sine squared instead of the cosine squared?
Because there was a cosine theta without a square.
Yeah, exactly. We can't really do anything to the cosine. So if I had changed the cosine squared, I would have had to change the cosine also to something. And we really can't change that to anything involving sine. So our only option is to change the sine squared. Okay, let's combine our like terms. So I have negative 2 cosine squared theta plus 3 cosine, plus 3 cosine theta minus 1. Okay, let me just double check. Negative 2 cosine squared plus 3 cosine minus 1. Okay. I don't like that square term being negative, so I'm going to move everything to the other side of the equal sign so that it will be positive. So 0 equals 2 cosine squared theta minus 3 cosine theta plus 1. Okay. All right. So now we have to factor. Say 2, 1. They're going to have to both be negative. So we get negative 2, negative 1. So that's going to work. So we have 2 cosine theta minus 1 times cosine theta minus 1 equals 0. 2 cosine theta minus 1 equals 0, and cosine theta minus 1 equals 0. So this will give me cosine theta equals positive 1/2. So theta equals the inverse cosine of 1/2. And over here we'll get cosine theta equals 1. So theta equals the inverse cosine of 1. Okay. So what do we have? We've got two equations that we're looking at now. So we're looking to see where the cosine is 1/2. So that's going to be at 60 degrees. So theta equals 60. And it's going to be, okay, here the x is negative, so that doesn't work. Here the x is negative, so back down here. So this will be 300 degrees. And then I have to figure out where the cosine is equal to positive 1, which is right here. And what angle is that? 0 degrees or 360. So if I go back up, I've got to check. Okay, we are not including 360, but we are including 0. So we're going to list that answer as 0 degrees. Okay. When you're solving these, look at your domain. If the domain is in degrees, you want your answer to be in degrees. If the domain is in radians, we want our answer in radians. It's okay if you work it and think it through in degrees, but make sure you express your answer in radians. Okay? All right, questions on that? Okay, so for homework, you're going to finish this worksheet and make sure you upload it to Google Classroom. So we did 3 out of the 10, so you got 7 questions to do. Okay, don't see any weird ones here. Yeah, everything looks okay. Not even, I already did the tangent, so they shouldn't be too bad. Okay. All right, so now we know how to solve basic trig equations and quadratic trig equations.